Hi. Whoa, nice and loud. Everybody can hear me, I'm sure. Thank you for everybody who came in the last few minutes, because at one point here I was looking and I saw like 3 people and it was going to be kind of an empty thing. We were going to go an entirely different direction. So I'm from Wisconsin, the middle of nowhere, Wisconsin, as he pointed out. And it's not exactly the most well-known place in the United States. For those of you who aren't familiar, it's in the Midwest, in the northern part of the country, and I live in the most northern part of the state. It's a beautiful area, lots of wildlife, lots of trees, not a lot of people. We're not exactly known for having a variety of interests. In fact, if you were to ask anybody else in the States, they'd probably tell you that Wisconsinites are known for 3 things in particular: cheese, beer, and the Green Bay Packers, which is an American football team. And yes, I know American football makes no sense because only 2 people ever touch the ball with the foot. It makes no sense at all, but to be fair, us Americans aren't really known for making a lot of sense, especially lately. The beer came later, but I very quickly became a big Packer fan early on. And so I remember the first time my parents scrounged up enough money to take me and my siblings to a game at Lambeau Field to see the Packers play. I was probably 7 years old and I was absolutely ecstatic. It was the middle of winter, so it was very, very, very cold. And the stadium, as you'll notice, doesn't have a dome. There's no protective thing above it. So you have swirling winds, you have cold metal benches, you have way below freezing. So it wasn't long before me and my siblings and my parents, we all kind of looked like human ice sculptures sitting there watching. And I watched in horror as one by one my family slowly faded in resolve. And eventually my parents told me the inevitable: we were going to have to leave early and head home. Now, naturally, I was pretty upset about this, so they decided that to appease me, they would let me pick out a souvenir on the way out. So as we were walking out, we stopped at a booth. Now, this is not a store. It was a glass booth, probably about this high, with metal trim all the way around. Now, at the time, again, I was 7, I had this habit. Anytime I was really concentrating, like really focusing hard on something, I would lick my lips like this. Like, that was my sign of intense concentration. Thank God I ditched that eventually. At the time, I thought it was basically the same thing as Michael Jordan sticking out his tongue, when he played. The only difference was he did this when making amazing plays against the best athletes in the world. I did it while taking like 2nd grade spelling tests and apparently picking out souvenirs. So there I am, below freezing weather, at a glass souvenir case with metal trim, licking my lips as I try to figure out what souvenir I'm going to get. And some of you may be able to see where this is going already. Has anybody ever seen the movie Christmas Story? There's a scene, right, where he sticks his tongue against a metal pole. Yeah, this is what happened to me. I'm sitting there licking my lips really close to the counter, trying to figure out what I want, and suddenly I realize I can't move my tongue. I'm stuck. Naturally, I was a little freaked out by this. I had heard about this sort of thing, but I had never experienced it, let alone seen it. And my parents apparently had never heard of this either, because they didn't realize what had happened. They just thought that their little kid was taking too long picking out the souvenirs. So they did the age-old tactic employed by parents around the globe. When your kid is taking too long to do something, you pretend like you're going to leave. You turn and you say, "Okay, well, I'll see you later," and walk off. Now, naturally, you're never going to leave them. I mean, depends on the day, but no, you're never going to leave them. But I didn't know that, and I was horrified because they're walking away. And so I tried to yell after them, I'm stuck. Although to be fair, it sounded more like, I'm stuck. But somebody pointed out this is going to be recorded. I had unfortunately already kind of planned on doing this, so we'll have to see if we can edit that out. No, but so I was yelling after them, making no sense, and they just kept going. Now, thankfully, the lady behind the souvenir counter figured out what was going on, and she called them back, and my parents, not knowing exactly what to do, bought a cup of hot chocolate, poured it on my tongue, and then pulled. It was not the most enjoyable of experiences. Now, what I didn't realize at the time, but I realize now in retrospect, is that I wasn't just suffering from a frozen tongue. What I was experiencing when I saw all those options was called choice paralysis. It's something that Barry Schwartz famously talked about in his book, The Paradox of Choice. The idea being that as we get more choices in front of us, it becomes harder and harder to make a decision. The freedom of choice becomes a tyranny of choice. Now, there are limitations to this, but certainly any couple who's ever sat down and tried to figure out what Netflix show to watch at night can tell you that this is a real thing. When our brains are presented with an abundance of options, we struggle to process them all, and we struggle to process all the possibilities, and we end up feeling a little bit overwhelmed. That's an increasingly common sentiment in the web industry, this idea of feeling overwhelmed, feeling like we're falling behind. And in no spaces is quite as apparent as in the JavaScript community, where new tools and new frameworks seem to pop up every single day. Towards the end of the year last year, somebody wrote a tongue-in-cheek sort of post about what does it feel like to learn JavaScript in 2016. It was meant to be humorous, and I thought it was. It started by explaining like they had a specific situation that they wanted to solve, so they ask someone, and they say, well, go use this framework or this tool. And so they start reading about this one, and they find another problem, and then they're told, well, actually, you should be looking at this tool to fix that. And so the entire post is them bouncing back and forth between all sorts of tools and frameworks and libraries as they try to solve what had been a very simple problem at the beginning. Now again, it was meant to be humorous. It wasn't meant to be, vindictive in any way, but of course this is the internet. And so a lot of people got really riled up about this. And so there were a lot of follow-up and spin-off posts. We started talking about defining what this JavaScript fatigue thing is and trying to figure out how do we manage JavaScript. It got so bad that we started to see posts about JavaScript fatigue. This feeling of overwhelmed, it's a very real thing. The web moves incredibly quick. In an environment that moves this quickly, being able to distinguish between what matters and what doesn't is an essential skill. When it comes to frameworks and libraries, we need a critical framework for evaluating them. I don't think that there's enough. We're a little protective of our tools, as I think the response to that article sort of showed. A good tool can be very endearing. We use it, it helps us make us more productive, and we become very attached to it. We don't see enough critical discussion about these. Now, the upside is definitely discussed. The theoretical promise of frameworks is discussed widely. Frameworks are abstractions. And like any abstraction, they attempt to make things easier, to simplify. Probably the best example of this that I can think of is jQuery, right? Now, jQuery is not the hot topic anymore. You don't see it. There's not that many talks about jQuery. Specifically, it's moved on to React or Vue or Angular or whatever it happens to be. But jQuery has an unparalleled dominance. Of the top 500,000 sites, React has a 0.4% penetration rate. Vue has a 0.2% penetration rate. jQuery has an 82% penetration rate. jQuery dominates like no other. And it's because they took JavaScript with all the different cross-browser bugs and all the kind of funky little methods built in, and they abstracted it and made it very simple. So this is what it looks like if you wanted to make an AJAX request, cross-browser, IE9 support and up, right? You open an XML HTTP request object, you set the URL that you want to make the request to. We have an onload listener here, so when something comes back, we check the status, and if we have it, and we're assuming in this case we're looking for JSON, we parse the JSON and then do something with it. And then of course we have an on-error handler in case something goes wrong, and finally we trigger it. That's how we do an AJAX request. Not particularly terrible, especially if you remember like earlier days trying to navigate some other waters. But this is what it looks like to get JSON via an AJAX request in jQuery 3.0. That's it. There's a getJSON method that you call. It has a sort of a promise-based interface, so you have a done and you have a fail. You react to it and you're done. So we move from this to this. It's much easier to read, much easier to understand, much easier to get started. That's why jQuery is so popular, and that's why frameworks and libraries have so much appeal, because they can simplify. And because they make things simpler, they improve productivity. We can have people of all sorts of different experience pretty quickly get up to speed using them. And as a bonus, they come with their own built-in documentation, hopefully good. Any good library should have some really good documentation. So that productivity boost, that simplification, that's what frameworks potentially provide. But here's the thing. Everything has a cost. They come with a cost. That's not a free trade. It's interesting when we evaluate the cost of frameworks. We evaluate frameworks. Like we always start the discussion by pointing them against each other. React versus Angular versus Vue versus Ember. But that's the wrong place to start. If we really want to critically evaluate whether or not we should be using a particular framework, we should be starting at the core. We should be comparing using that framework to not using one at all. You have to be able to understand the core to maximize the abstraction. So for example, here's what a browser does when it wants to load a web page. Right? There are 3 asset types that it considers above all else. These are the most important: HTML, CSS, and JavaScript. Now, it needs the HTML because as soon as it gets that, it has to parse it and create a document object model, a representation of all the different elements within a page. Here we're just seeing the elements, but you can see there's text in there, any attributes that would be attached to these elements. All of that exists inside the document object model. It needs this because without this, well, there's nothing. The page does not exist. It needs CSS because it needs to do the exact same thing with the CSS. It needs to construct a CSS object model. It needs to parse all the CSS, create a representation of all the potential selectors that might apply to the document object model. Now, eventually, it's going to marry these things together. That's how it gets the render tree, and that's how it gets on with actually displaying content to you. But it has to do this first. Now, JavaScript is the other highly important asset type, and the reason is because JavaScript can mess with both of them. JavaScript can change the document object model. JavaScript can also change the CSS object model. So the browser has to assume the worst. It has to assume that any JavaScript, unless you've specifically told it otherwise, any JavaScript found on the page is going to potentially mess with one of these things. So that's why it's a blocking resource. That's why it needs to get it as early as possible. What happens is that it's parsing the HTML, it finds a script element, it pauses the HTML parsing to be able to get a hold of the JavaScript, potentially execute the JavaScript, and then finally continue on its way with the HTML parsing. JavaScript it stands in the way. Now this is relatively straightforward, right? And it is pretty simple, but already it reveals one kind of a big thing, which is that JavaScript, if we're not careful, can turn into a pretty big performance bottleneck. It needs to be done up front. And it stands in the way because we have to actually bring it down, we have to parse it, and we have to execute it. So there are a couple ways we can try to deal with this, right? One way is to defer. We want to defer the JavaScript loading as late as possible. Using the async attribute would be one method of doing this. What happens then is it finds the script tag with the async attribute, but it doesn't stop parsing the HTML. Instead, it parses in parallel. And once the JavaScript's been parsed, then it'll execute and move on its way. So you reduce the bottleneck quite a bit. This is great. However, if we're using any of the all-in-one frameworks or libraries that, like Ember or like React or like Angular or like jQuery, that's going to do substantial changes to our pages, moving that stuff asynchronously doesn't make a lot of sense because then you end up getting some stuff displayed, the script gets enacted, and then it just starts moving everything around, and you get this sort of rejiggling. That's not a technical term, but we're going to run with it. A rejiggling of all the content on the page, which is not at all appealing from a user perspective. So there's a limit to how much we can do with this and frameworks. So our other option is just to load less JavaScript. The less JavaScript, the quicker it'll parse, the quicker it'll execute, the quicker the browser gets to move on. Unfortunately, we don't do a particularly good job of this today either. The average page, according to HTTP Archive, is pulling in 0.5 MB of JavaScript. 0.5 MB. And that's the compressed size. That's the size of the file being passed over the network, which hopefully has some sort of compression like gzip applied to it, right? So the network cost is very, very different than what the browser actually has to deal with. Because the browser has to download it, it has to parse it, it has to execute it, it has to evaluate it. The only thing that the compression helps with is the download. Everything else, it's dealing with the uncompressed size. And this becomes very expensive. So not to pick on Infoshare, because this actually is not out of the norm in any way, shape, or form. But if you open this up inside of Chrome, you can do a performance analysis of it and let it total these up by the different activities. And you'll see that 40% of the time spent loading this was on a MacBook Air on hotel Wi-Fi. 40% of the time loading this was scripting, meaning not the downloading, meaning the execution, the parsing, the evaluating, the compiling, all of those steps. It's a pretty involved process. Adi Osmani from Google wrote a really good article, highly recommend checking it out about JavaScript startup performance. But in there he had this nice little whimsical, I guess is the right word, diagram of like what happens inside of Chrome when it gets JavaScript, right? It has to take it, it has to parse it, it has to turn it into a syntax tree and generate some bytecode. Then it looks for some speculative like optimizations, like are there shortcuts it can take to make it a little faster, tries to optimize and compile it, and then it actually has to run it. All of this stuff happens in the background, and all of this can add up and significantly slow down the startup of a page. And again, this is dealing with the uncompressed size. So these are 5 very well-known popular libraries: Ember, Angular, React plus React DOM, because React by itself, jQuery, and Vue. The file sizes you see here are if they're minimized and compressed with gzip. So if you loaded these files and you passed them over the network, this would be the network cost. Mostly this is manageable, right? I mean, you could question a couple of them. But these are relatively reasonable sizes. But they're very misleading. Once the gzip compression is taken off, so once the browser has it, this is what it's actually dealing with. This is minimized. It's dealing with almost half a meg with Ember, and then 163, 146, 85, 77. That's what it has to actually parse, evaluate, and execute. It's a very expensive process. And it's more expensive on mobile devices than desktop. In that same article that I mentioned about Addy before, he showed the same page loaded over desktop versus overloaded mobile with a lower powered CPU. And you can see the parse and compile time is dramatically different. We jumped from 200 milliseconds up to a full second just to parse the JavaScript on this particular page. This is one of those things, this is one of those performance areas that is not in any way, shape, or form consistent across experiences. This is, you can't see the numbers, and that's fine. This is a whole bunch of different devices that he had tested 1 megabyte of JavaScript in terms of parse time. And this is the difference. At the top, you have a MacBook Pro, and at the bottom, you're starting to get into all these mobile devices with all these different CPUs. So even if you're testing something like this on a desktop and it looks like it's fine, that doesn't mean that somebody down and using some mobile phone is not going to spend 6 seconds just parsing the JavaScript loaded on a page. This is pretty expensive. Now, how many people have heard of perceived performance? Yep. All right, so perceived performance, for anybody not familiar, I'm actually a really big fan. Perceived performance is all about making things feel faster. Potentially you're loading in some sort of a skeleton screen so that it looks like the backgrounds are all coming into place and the content kind of fills in on top. You do these optimizations to make people feel like the site is going a little faster. It's a fantastic thing to do. You should absolutely be doing it with your sites and applications, but it is not a get out of jail free card for performance issues. There's a limitation to what it can accomplish. So for example, while the browser is doing this document object model and creating that, it's actually in parallel creating what's called an accessibility tree. It's like the document object model, but it's kind of a subset of it. It's only the information that is actually useful for anybody using screen readers or some other assistive technology. There's no perceived accessibility. This stuff just takes as long as it takes. There's nothing we can do to shortcut it. So if we have a lot of scripting going on, a lot of parsing, a lot of changing of the document, the accessibility tree is just it's gonna take a while before it's all set and ready to go, and there's not much we can do about that. The accessibility tree actually highlights a few risks that we have, though, in terms of using abstractions without understanding what's happening under the hood. So again, going back to the Infoshare site, if you go to scroll down on the home page, there's a section where it's listing all of the different speakers on the page. And if you were to click on any of these speakers, you go through and get some information about them or whatever their talk happens to be. So if we inspect them, what we'll see is that this is actually a div element with an image inside, and then another div, class title, and then inside of that is actually a header and a little bit of text, the URL or the company that they're actually associated with. Now, if you click on this div, it then fires you off to the second page. But this is, because this is div and because this is generated by a script, we actually are starting to lose some of the default information we would have had available to us in the accessibility tree. So if we were to inspect this again in Chrome and dig in and see what this actually looks like, we'd see that there's a lot of properties available inside of the document object model. A lot of details, a lot of built-in logic, a lot of built-in information that the browser can use, that we can use inside of scripting. It's very fleshed out. There's a lot of information. However, inside of Chrome, there's an accessibility experiment that you can enable, which shows you the accessibility tree. If we look at the accessibility tree, it's much more sparse. You'll see that what we have is a div, and we have a heading, and we have a text, and we have image, but there's nothing inside of that accessibility tree whatsoever that tells any sort of assistive technology that this is something you can interact with. There's no clue that this is a link, that you can do anything with this, like what is the context of it. It's just non-existent. And this is why. Let's look at the div specifically. You can see everything's controlled by data URIs here. We've got data attributes. We've got data URL hash, data href, data fancy box width, a lot of good information. Very handy for scripting. When the document object model is created, we've got the div. We have each of these attributes as some sort of a subnode inside of the tree. We have all that information. When the accessibility tree is created, we have a div. The class doesn't mean anything from an accessibility perspective. The data attributes are not anything that is standardized. They're not anything that is, like, in terms of consistent data URL hash, it does not know from, it can't tell what that's supposed to mean or what the point of this is. So the accessibility tree is extremely limited. Now you can actually help this out. This doesn't mean don't do this. It means that if you're going to do something like this, we can sort of extend on top of it using ARIA. So here I've just added one line. We're applying ARIA label, which is saying, this is specifically for assistive technologies. We're saying we're going to give a label to this so that screen readers, any other assistive technology knows exactly what this is. Learn more about Vitaly. And then we have role, which tells the assistive technologies what this is meant to do. This div is a link. It's meant to act as a link. Now, when the accessibility tree is created, we have, instead of a div, it sees a link. It sees what it's supposed to do. And then it has the label that it can actually, get some information about. Now, if we inspect it again inside of Chrome, we see it's very different. Instead of group region div, as we saw before, now there's a link, there's an image. You can see that there's information below in terms of the properties around the label. We have a much more robust accessibility tree. The assistive technologies can do something about it. ARIA is useful, but it's not a get-out-of-jail-free card either. There are still limitations. So frameworks, a lot of the frameworks, if you're building custom components, a lot of times this pay attention to the assistive technologies is not really given. That stuff just doesn't exist by default. Some of them have done a good job of creating modules that assist with this. The first, Angular is a really good example. So this is a custom checkbox component created inside of Angular. Angular has a module specifically for ARIA, ngm ARIA. And if we pull that into our module here, you can see that's in the brackets. What it's going to do is silently in the background, it's going to detect that we're using a checkbox. It assumes that we're going to be sort of intelligent about hinting it about what the functionality is here. But it sees that we have a type of checkbox, and it's going to add on the appropriate ARIA labels and roles on our behalf, so we don't have to worry about it. It bakes that accessibility back into it for you. It's great. It adds us that information that we were looking for, but it still doesn't give us a fully complete accessibility solution. We still have to do a lot on us. If you noticed on the first screen here, we still have to, by ourselves, have the ARIA label to give it some sort of information about what this is. Also, within the actual component, we still have to specify a few other things. We have to make sure that we've accounted for keyboard accessibility. So if a key is pressed on this, because oftentimes they're going to be navigating by a keyboard and not a mouse, and you want to be able to still fire off to the link. And add the ARIA hidden true around some other markup. You still have to go through the steps necessary to add all of this stuff in there. A lot of this is baked in by default if we use semantic markup from the beginning. This is 3 buttons. All of them would link off to Infoshare. All of them look identical. All of them, if I hover over them, do the exact same thing other than the little mouse pointer, because apparently I was lazy. But if we turn on VoiceOver, we get a very different experience.
Chrome, ready. You are currently on a button. To click this button, new tab, switch first back, but read, bookmark this page, Chrome, but visited, link, Infoshare. You are currently at Infoshare button. You are leaving HTML content. Close accessible buttons button.
Now, if you saw anything that was happening there, here's what happened. Once we got to the links, the first one, it said visited link Infoshare. The second one, it said Infoshare button. And then we tried to tab to the third one, and it kicked us back up to the URL bar. We could not get to it. It's because even though functionality-wise they were exactly the same, the markup is very different. And depending on what the browser sees for the markup, it's going to do entirely different things. So the first example was a link. And because it's a link, it understands what the functionality is supposed to be. It's able to augment that with information about whether you visited in the past or not, which is very helpful information. It's able to give you some default baked-in behavior. The second example was a button. We would have had an on-click handler or something like that attached to it. Now, the button means something entirely different from a semantic perspective. And so the browser doesn't have the information about that this refers to another page and can't tell that you've actually visited. It's meant to do a very different thing, even though they're often used interchangeably. And the third is just a span, an empty element that we've added an on-click event to and styled to make look the exact same way. And again, the user has no information about what this is meant to be. In fact, this just doesn't exist. As you can see, it's not interesting, apparently, for accessibility. It doesn't mean anything. It's meaningless. So you have to be careful when we're pulling in these frameworks and these libraries and we're creating components, what they're using under the hood. A lot of these libraries will generate something like a button when a link would be more appropriate, or an empty div or an empty span for a link when really you should just be using the link element to begin with. If we don't pull these frameworks and libraries in, if we don't evaluate them critically, then we risk giving up some accessibility and leaving a lot of users out by default. Risk is it's a word we don't often hear in discussions, I think, about frameworks. But it's a very real thing. When you pull this third-party code into your application, you're offloading a lot of the responsibility, but you're assuming all of the risk. If something goes wrong, it's on you. It's your users who suffer. It's your business who's going to suffer in the process. Now, this risk takes many forms. We've talked about performance. We've talked about accessibility. It also takes the form of the general security and well-being of your site or application. So recently, I took the top 5,000 Alexa URLs, and I tested them to see, just for 10 libraries, a sampling of libraries, to see who was using what library and what versions. Once I had the list of all the versions for the libraries, I ran them past Snyk's open source vulnerability database to see if there were known vulnerabilities attached to those versions. Now, I was expecting, maybe like 20%, 30% probably in terms of how many sites had at least one known vulnerability in a JavaScript library, but it turns out that the number was 77%. 77% of the top 5,000 sites have at least one library with at least one security vulnerability. And again, this is a small sampling of 10 libraries looking at only known vulnerabilities. This is not any sort of proactive scanning around finding other issues in terms of the site. So that number is only going to go higher once you expand your reach a little bit. 77%. Now, that doesn't necessarily mean that all of these sites are exploitable. Right? A lot of the way the vulnerabilities work is a certain method has to be used in a certain way for that vulnerability to be exposed. Now, and that's a tougher thing to test, at least in bulk, without going back through and checking. Right? So it doesn't mean that they're all exploitable, but it means that they all have a kink in the armor. They're all one developer, one function call away from potentially leaving a big, wide hole for attackers to take advantage of. So you remember our abstraction that jQuery offers for Ajax? So this is the get method, right? There's a really interesting, and it's interesting, I think, from the perspective of why it happens. There's an interesting vulnerability in versions of jQuery prior to 3. There's the window between like 1.4 and 1.12 something or whatever, where it's a cross-site scripting bug, which is, for anybody not familiar, means an attacker is able to inject some sort of script where it's not supposed to be and potentially get information out. Every time we demo it, including what you're about to see, you just see like an alert. But anywhere you can get an alert, you can do anything with JavaScript. You can get all sorts of more interesting information. So if we take a look at this page, this is it's very simple code. We just have a link that says click me, and we have a little bit of a script that grabs the link, adds an event listener, and then it just fires off the Ajax request to this URL. Nothing else. That's all it's doing. But as soon as we click it, we see that an alert pops up with some information. In this case, just a generic message. But there's nothing in that code that should ever be executing anything. It's supposed to be an abstraction of just the XML HTTP request. That's all it's supposed to be doing. That's all I expect it to do. But jQuery was trying to be opinionated and trying to be helpful. And so what they said is, you know what, if you're going to fire off an Ajax request and you're not going to specify the data type, but we see that it's JavaScript, we'll evaluate it for you. We'll be helpful and friendly and evaluate it for you. So anytime you made a request to some other URL, if JavaScript came back and you hadn't specified that you were looking for a specific different type of data, if JavaScript came back, jQuery was going to be nice enough to automatically evaluate and execute that JavaScript for you. So it leaves you wide open and exposed. And this is exactly the kind of vulnerability that no developer, unless they looked under the hood, would ever anticipate. You would never think that the AJAX request would also automatically execute any script response. It's just not something you would have considered. Now, the somewhat sad thing, too, about all of these 77% sites is that in each case, there's a version of the library that does not have those vulnerabilities. They could update and get themselves to a point where they're not vulnerable anymore. For every single library tested, over 50% for each library, the majority of use for each library was over 2 years old. For jQuery, the age 62% of the jQuery libraries found in production are over 3 years old. We don't really keep them very up to date. The maintenance is another thing to consider when you're considering whether or not you're going to pull in a framework or a library. Now, part of this, I think, is the fact that package management hasn't really taken off on front-end development to the same way that it has on back-end development. Options exist, Bower, npm plus browserify, things like that you can use to specify what libraries you want to use and what versions, and then theoretically it continues to update for you. Those exist, but they're not used to the same extent as sort of a Maven or a Gradle or a Ruby Gems or something like that that's used on the back end. That's part of the reason, but part of the reason is just the lack of visibility in these issues. Again, the web moves quick, and it's a little bit of the Wild West, and so when we're talking about these security issues, there's not a really good dedicated way to get hold of the information. For a lot of libraries, they'd never really actually publicized the fact that this version versus the other version fixed the vulnerability. We have a dedicated team that is, their whole intent is to maintain the database, and they end up having to go through GitHub pull requests and mailing lists and comments on issues, and that's how you track down half of the vulnerabilities that we find. They're not formally released or broadcasted in any way. Now, granted, you can do something. You can use like retire.js or NSP or Snyk or something like that to monitor these dependencies to see if there are issues, and if there are, get alerted to them and potentially have them fixed through some sort of an automated process. But all of that assumes that you know enough about the problem space, that you care enough about the problem space to actually look for a solution. It's why I always kind of chuckle a little bit. Whenever somebody points out to someone else, I've seen it a million times where somebody will write a post about so-and-so framework is not performant or not accessible or whatever it happens to be, and somebody will jump in on the comments and say, well, that's because you're using that method. Don't use that. Use this. Set this property. You're right. You can fix a lot of this stuff if you use some other method, but it involves you actually learning and investing the time and getting to that expertise level on the framework. It's the same problem that you have with sort of the core code. You still have to get to a point where you know it well enough to know what to fix. And a lot of the times the defaults aren't very good. The default methods aren't performant. The default methods aren't secure. They're not accessible. Angular has the additional module, but it's not baked in. It's something you have to know about, and you have to understand that there's a need, and you have to pull it in. It's not there by default. And people stick with defaults. We've seen it over and over and over again with study after study. Defaults matter. People stick with them because they're frictionless. They're the path of least resistance. And changing them requires not just taking the time to do it, but taking the time to learn how to do it and where to do it. They have a cost. And I guess that's the thing about all of these issues, the vulnerabilities, the accessibility, the performance, the cost of maintenance, the overhead of learning. They have a cost. They're not free. Using a specific tool and using it well is not something we should take lightly. It's something that takes dedicated time and effort to get to that point. We're framework optimists. We hear a talk or we read a blog post about a certain framework, and we always think, oh, wow, that sounds so amazing. I've got to use that. But we always forget that it's within that specific context. It's amazing within a specific context of use. There's no one-size-fits-all solution when it comes to frameworks or libraries. There's no framework that's going to fit everyone's workflow, fit everyone's process. It just doesn't work. Everything must be evaluated in the context of our own situations and our own applications. And that includes, by the way, all the concerns I brought up in the talk. You know, you may be thinking at this point that, like, God, Tim is kind of a, I don't know, is negative Nancy a term over here? But like, Tim is like a negative Nancy. Like, he's really down on frameworks. He hates these things. It's not the case at all. It's not. In fact, use React quite a bit, jQuery quite a bit, Vue, not in production yet, but playing around with it and really enjoying it. I like frameworks, and I think frameworks are not the problem. In fact, I think that we are lucky as all get out to have an ecosystem that is this vibrant, an ecosystem where everybody is building different tools and sharing them and putting them out there so that other people can use them and pull them into their projects. That's pretty freaking incredible. But it's important to remember that all of this stuff is relative. The benefits are relatives, but so are the downsides. I can tell you what the potential costs are. I can warn you that there's accessibility concerns, there's security concerns, performance concerns, but only you can tell if in the context of your application, those concerns outweigh the benefits. If that means that you should not use a framework, or if it just means that you need to take a few additional steps. You know, we have this constant tension in our industry between innovation and stability, between known and unknown technologies. And the innovation, like the new stuff, the stuff just coming out, that's always really, really exciting. And it drives us crazy sometimes, but we don't always have to be all the way over here. Right? Innovation is great, but stability matters quite a bit. We obsess so much about what's next that we often miss the potential of what we already have. Pick your battles. Focus on the core technologies. If you're going to invest or over-invest time and energy, I would err on the side of investing your time and energy on understanding the fundamental core technologies that everything else is going to be built on. Because if you understand that stuff, then it's much easier for you to move between today's framework and tomorrow's framework. And don't worry so much about feeling left behind. You know, if we saw the penetration rates where it's like 0.4% React, yeah, React, if you go to a conference, though, boy, it feels different, doesn't it? It feels like everybody's using it because everybody's talking about it. It doesn't move quite as quickly as it seems. Slow down, give your brain some time to connect the dots, you know, make sure that you're critically evaluating all of these tools and see the incredible possibilities of the technology that we have available to us now. If we do this, not only are we going to feel not so overwhelmed, but we're going to start building a web that's more performant, more accessible, more secure, and more usable. Thank you.